Andy Weir's book The Martian and the 2015 film adaptation of the same name tell the story of Mark Watney, an astronaut left behind by the Ares 3 mission. One piece of equipment critical in the story is a device called the oxygenator, which produces oxygen for the life support systems in the hab where Watney lives. This video will discuss the real science that provided inspiration for Andy Weir's story. Hi everybody. In this video I'm going to be discussing the MOXIE experiment included with the Mars 2020 rover Perseverance. If this experiment is successful, it is going to generate oxygen from resources available on Mars. This would be really important for any future missions because it could be scaled up to produce oxygen for life support systems and fuel for a Mars ascent vehicle. The Mars 2020 mission is scheduled to launch between July 17th and August 5th, 2020, using an Atlas V541 rocket like the one seen here when Curiosity launched back in 2011, and is scheduled to land on Mars in Jezero Crater on February 18th, 2021. The oxygenator is based on a component of the Perseverance rover. The component is called MOXIE, which stands for Mars Oxygen In Situ Experiment. The lead scientist for MOXIE is Michael Hecht of the Massachusetts Institute of Technology. The Niels Bohr Institute of the University of Copenhagen is working with MIT to build this prototype. This component of Perseverance will use a process called electrolysis to split carbon dioxide to form carbon monoxide and oxygen gas. NASA already uses electrolysis of water to generate oxygen for the crew of the ISS. The process of electrolysis splits water molecules by using electric current and produces hydrogen and oxygen gas. Use the video link if you want to learn more about electrolysis. So if splitting water is providing oxygen for the crew of the ISS, why not do the same thing on Mars? The answer is that even though there is water on Mars, there are challenges to being able to get enough water. So a process that uses water to generate oxygen would be a bit like robbing Peter to pay Paul, paying one debt by taking on a new debt. A better solution would be to generate oxygen using something you don't really need. So what could NASA use? Fortunately, there is a possible solution. The atmosphere of Mars is over 95% carbon dioxide. So if you could split the carbon dioxide into carbon monoxide and oxygen, you'd have a source of oxygen that does not use up your water supply. The electrolysis of carbon dioxide, or CO2, produces one molecule of oxygen, O2, for every 2 molecules of CO2 that are being split, as shown by the equation and image. The process is an example of oxidation and reduction. Reduction happens at the cathode, producing carbon monoxide and oxide ions. Oxidation happens at the anode, where the oxide ions join to form the oxygen. This figure shows the MOXIE functional block diagram. Gases are brought into MOXIE through the CO2 acquisition and compression, CAC, system seen on the far left. These gases, which are 95% CO2, are then compressed to bring to a pressure of about 1 atmosphere. To match conditions on Earth. The CO2 is then sent to the solid oxide electrolyzer, or SOXY for short. The solid oxide electrolyzer runs at a temperature of about 800 degrees Celsius, so there is a thermal isolation system designed to prevent these high temperatures impacting other instrumentation on Perseverance. Gases leaving SOXY enter the composition measurement component, where the purity and production rate of the oxygen can be measured. The oxygen is then vented along with carbon monoxide and any unreacted carbon dioxide through the exhaust system. The MOXIE experiments will last for 2 hours and be conducted intermittently for the duration of the Perseverance mission. It should generate 10 grams of oxygen per hour while running. To put this in perspective, an average person would need about 840 grams of oxygen each day. This means you would need 3.5 MOXIE units running 24/7 to support one person on Mars. If MOXIE is successful, NASA could build a much larger unit that would produce enough oxygen for life support for human exploration of Mars and provide fuel for a Mars ascent vehicle for returning samples to Earth or for future human explorers. Thank you for watching, everybody. Please keep checking back to my channel for additional videos about Perseverance and the Mars 2020 missions.